Sorry, did you try to join? Oh, I'm sorry. Okay, Ryan, hopefully that looks okay for you. Oh, stop writing that stuff on there. Come on. He's going to think this is a joke. All right.
No joke.
So no joke here.
We're taking this
All right, Ryan, just make sure that if you're in, you want to hit unmute when you want to talk, okay? So I can hear you. Oh, hey, I can hear you. Perfect.
Can
That's
Ryan
great. Okay,
see
now
it
you can
on
still see me on
Ryan?
camera, right? But then you can also see the
Erica,
iPad
can
screen.
you see it?
Is that correct? Yes. Perfect. That's what
You
I'm
can
hoping.
see both?
Yes. You can see me walking around, and you can see the iPad.
That's pretty cool.
Yeah.
I'm proud of that one.
I'm proud of that moment. I'm real proud of it. I thought the big brain on Brad here. Oh man. So, all right, here we go. We have a couple things. We have a couple things we have to do. Morgan, don't be drawn too much because they need to follow along with the notes. So the first thing for notes here, you need to hit mute.
I know, I did. I was
Okay.
just trying to.
All right. So.
Hear everything.
Okay, all right, first of all, let's go through the first example. So Morgan, off to the side in your paper, you're gonna have to write these problems down. You might want to even take notes yourself too. Okay, so, and if you want, Morgan, you can probably take screenshots of that iPad when you get
Oh,
going
I
too.
can't see Ryan.
All right, now, the first type of problem, I'm gonna use the one that I did yesterday. So if you were not here yesterday, I'm gonna pick something like this. And let's go with x squared plus 4x plus, or let's go 4x minus 5. Let's do that. All right. All right, my goal today, this is it. I'm not joking. My goal is to get through 2 major problems today. 2. These are the other types of situations that could happen on a rational function. So now the section we're in rational functions. So we're in section I think it's 1.6. It's called rational functions, and we're graphing. Yeah, it's the same section.
After.
Can you change the color on this?
Okay, now
No.
let's walk through what we can do with these rational functions here. Okay, so the first thing we were talking about was like all the different rules we followed. We had to talk about X-intercepts. I'm going to abbreviate. X-intercepts, Y-intercepts. Those have completely different rules how to find them. We saw that yesterday. We have asymptotes. Now, there was 2 types yesterday. We have a 3rd type today, which I don't think we've actually discussed ever.
Oh,
So the 3rd type of asymptote is called the slant. So we have vertical, we have horizontal, and we have slant asymptotes. This is the stuff we started yesterday, I believe, correct? Okay, now, we are going to go through. My goal today is to do a problem with slant. That's the first one. The second problem is to do one where the horizontal is at 0. We didn't see one of those yesterday. And so that's what we're going to be looking at for today's purposes. Okay.
He just got up and left.
Are you actually taking notes?
Yes, I
Okay,
am.
good. All right. And Ryan, you tell me if she's not following the camera. So.
He's making a sandwich.
Yeah, you just.
Oh no, he went and got a blanket.
Okay. All right. So first of all, let's talk about how to find the X-intercepts and Y-intercepts. What were the rules yesterday?
You have to.
Factor.
Factor the top. So we have to factor the top to figure out X-intercepts. Now the top is a cube rule. The bottom, I'm going to wait till later to do that. For the top, to factor a cube rule, the cube rule is, it's going to be a binomial in the front, trinomial in the back. The symbol will stay the same. So it's the SOAP acronym. Same, opposite, always positive. Okay? So, what you do to find this first parenthesis, and the first parenthesis, the important one, you take the cube root of x to the 3rd. Basically what you do is you just take the variables and divide by 3. There always have to be multiples of 3. What's x to the 3rd divided by 3? Just x to the 1st, right? And for the numbers, what is the cube root of 27? 3. It's important that you get the first, the first parenthesis correct. If the first parenthesis is wrong, we're going to have a major issue. Okay? Now, so now, on the next part, the symbol will be the opposite, because that's the acronym for SOAP, right? I'm using the SOAP acronym. Same, opposite, always positive. So opposite, and now the back symbol is always positive. That's the AP. That's always positive in the back. And now, to get the back trinomial, you just have to use the binomial up front to get all the terms that go in here. It's really easy. So you square the x. And if there's a number on it, you square that too. The 3, you square that. 9, that's in the back, right? The first item and the back item are squares. The middle is the 2 items multiplied together. 3 and x. And you ignore the symbol in between. I know there's a minus.
Wait.
Ignore it.
Where do we get x minus 3?
That was taking the cube root of x and the cube root of 27.
Oh, yeah, okay.
Yeah.
Oh, so you always keep the sign in the middle?
Yeah, the sign in the middle will always be in the front. That'll be the first parenthesis. Then the next ones are depending on what the SOAP acronym tells you. Opposite, always opposite. Right?
So the minus sign, if there's a plus sign, you do plus sign.
Yeah, so if this is a plus, it'd be a plus here, it'd be opposite, and then always
That's
positive.
how you factor for cube root.
I can't see
That's
that.
just blue water.
So the stuff in the back, where'd that come from?
The stuff back here is made from these two. So it's the first item squared, the back item squared, and then the middle item is these two things multiplied together, ignoring the symbols, negative and positives.
Okay.
That's how it always works with cube rule.
Alright.
That's the rules we talked about in Algebra 2 and pre-calc. So,
Must have missed that again.
yeah. So, all right. Now, if you do this correctly, this trinomial in the back will not be factorable. If you did it correctly, you won't even have to worry about doing to figure out the x-intercepts for this, like doing the quadratic formula, because it will be imaginary. That's how it always works. Just so, what is the x-intercept for the front?
3.
Yeah, this parenthesis, what makes it 0 would be 3. That's my x-intercept. So I only have 1. So my only lone x-intercept on this particular problem is a 3. Is there any questions with how I did that part? You set each parenthesis equal to 0. So if you have multiple parentheses, set each one equal to 0 by
Wait, so
themselves.
did you go by the opposite of the
So it's a
sign?
Yeah, it's basically the opposite of the sign. Or just, what I do is I set x minus 3 equal to 0 and solve, if you can't figure it out. Okay, now, the bottom is how you figure out where the vertical asymptotes are going to be. So those are usually the first 2 items. So if I number what order I go in, I do x-intercepts first, I do vertical asymptotes second, and then I'll go back and do y, and then I'll do horizontal or slant, whatever comes next. Okay? All right, so vertical, we have to factor the denominator. Okay, so if we factor the denominator here, how do we factor that? What's the rule? Trinomial rule. It's a trinomial. So it's going to be 2 parentheses. The minus sign in the back means that my symbols are automatically opposites. It's plus minus. Because the minus sign in the back says they're opposite. If it's a plus, they're the same. You have to go figure out what they are. So mine are the opposites. You break up the x evenly, and you break up the 5.
Plus minus?
5 and 1.
Because of the minus sign in the back. That tells me it's plus
Yeah, you're
minus.
correct.
If it was a plus in the back, they'd be the same symbols in each.
They're both negative?
If they're both negative, like here and here,
Yeah.
I don't care. Like the back symbol in the back, if it's negative, it's automatically plus minus. I don't care about what's in the front. If it's a plus here, then you have to look at what's in front of it to
So
see
they're
what.
both negative.
Yeah. So, all right. So in my case, it's plus minus. Now, how do we break up 5? 5 and 1, and it matters where you put them. I need to make a positive 4. So I'm going to go positive 5, negative 1. They have to multiply to give you the back number.
That's the only kind of factoring I know how to do it. Right there.
Well, that's probably the majority of what we do.
Good.
I thought that was how you were supposed to do it on the test, and it obviously was not, because that was very rough.
That is not how that's not how you're supposed to do it on the test. Because I tried that on the test multiple times.
Me too.
It didn't work.
I was gonna retake the test,
Okay.
but then I saw I just had an A minus. I'm like,
All right.
Live with that.
Now, vertical
I've
asymptotes.
never been one to settle, but I will.
Okay, vertical asymptotes. So there's 2 of them.
Negative 5 and 1.
Yeah, negative 5 and positive 1. It's whatever makes the bottom 0, because you can't divide by 0. So those are where my vertical asymptotes will be. So I'm going to have a vertical line at negative 5. That's a vertical asymptote. You cannot cross a vertical. There's no bound. It's a no boundary zone. And then positive 1. So how many pictures am I going to have to draw on this drawing? 3. There's one on the left side, one in the middle, and one on the right side.
And you don't go.
And I don't go across the bars.
it's vertical.
They're vertical asymptotes. Morgan, does that look better in yours?
How do you know it's
Yeah.
vertical?
Vertical is always what makes the bottom zeros. It's always vertical
Or
on the
this
bottom,
is
because you
different,
cannot
right?
divide by zero, so those would be the numbers that make you.
So the y-axis, the y-intercept is -5.
What was that?
The y-intercept is -5.
The y-intercept would be -27. So let's go to this. Let's go to
How
the.
do you know the difference? Okay, because the 3 made the x 0.
Yes.
Okay, so vertical makes the other one 0.
Yeah.
So how do you know which is which?
X-intercepts are always the top. Vertical is always the bottom.
Oh.
That's how you separate.
Oh.
X-intercepts are top. Vertical asymptotes are bottom.
Or, is there a way that if you always write on this, then you can put that on the screen so they can?
Yes. So I can do it that way where I can just have Morgan share like wirelessly to the screen up here.
Well, this compared to yesterday,
Way better.
way better.
Okay, good. I'll stick with that. It was an idea I had when I was sitting yesterday after school because we had time to like kind of work, and I was like, I could just use my iPad. I do that at home all the time anyway. I'm like, yeah, I should just do that, and then
How
I'll
do you
get
get
rid of
into
the glare issue.
How do you get into live feed from the?
I just wirelessly cast to my Apple box up here, and then it would just project the iPad screen up here.
I see. So it took you a while to figure out how to do this setup, right?
Oh, I got my
No.
my shirt.
This is what I do at home when I was live zooming with you guys during quarantine. So I just thought about, like, why don't I just do what I did like 3 months ago?
So why do you have 2 cameras going right now?
One's recording class and one is the live webcam.
It's starting to go next.
Website.
No, the stuff you got going on.
No, well, there's a reason why is I overcooked the processor and I probably melt the desk underneath it.
Oh.
And I've done that at home. I melted my desk at home with how hot the MacBook got when I was doing quarantine stuff.
We love
Because I had 5 different cameras going on, so I could switch between cameras. My hands, the iPad screen, the GoPros that were set up, and I had so much like computing cycles going, I melted the desk. I have literally like heat welts in my desk for my MacBook. It boiled.
You know, you love to see that.
Oh, yeah, I really like to see that.
Cooking your
My
laptop.
my $3,400 laptop is so hot it
All right,
melted to
now,
death.
let's go to number 3 here.
Wouldn't
Hey.
you think that they would stop Max from getting so hot?
Yeah,
From being on
it's
the so much?
thermal is the thing that they always have to worry about. It's always the number 1 problem with computers right
Well,
now.
they don't blow up, do they?
But I've never had other laptops.
No. All right.
I've
So-
never had other laptops except Max get that hot.
It's metal. It's a metal chassis instead of plastic. Okay, all right. Anyway, Y-intercepts. You have to go back to the original problem and figure out what makes the top when you plug in 0 for all the X's,
Chassis melt.
and you have to figure out what the Y number is when you plug in zeros. So the easiest way. So, question? Or you know?
No, I'll ask later.
Okay, so for the top, it's whatever, when you plug in zeros into all the top for the Y-intercept, you get a -27 out of that thing. That is my Y-intercept. My Y-intercept is a -27. Now, I don't have that, so I'm just gonna put it down here and say -27. Down at the bottom.
You figured that out because that's what you'd have to plug in to make it 0.
Well, no, it's just when I plugged in zeros into the top for all the X's, because that's what a Y-intercept is. Y-intercepts have a 0 for an X, and they have a number in the back. So all I did was plug in zeros for all the X's.
Oh, okay.
And
So
solve.
for that 0 right
Yeah.
there. Yeah, okay.
So,
I didn't get that. Say that again.
all right, for a Y-intercept, you have to plug in zeros for all the X's
On the
and then
top.
go draw it.
On the red on the top.
Yeah, I don't think you have to do it to the bottom. I don't think the bottom
So
applies.
0 minus 3.
Ooh, could you do it to the bottom? And that would
Well, you
make,
do it different.
that would make -27 over -5. Ooh, I wonder if you have to on this one. Oh, hold on.
We got problems. We got problems.
Ooh, I didn't even think of that.
What? What did I miss?
We got problems.
Wolfram alpha. Hold on.
What?
You just
What did I just miss?
Word
Divide it by
type
5.
How did you not see that?
I wasn't paying attention. I was watching more.
I've never seen an epiphany of that sort.
You just said,
I was watching.
that was a brain melter right
I was
there.
watching Ryan look confused, and then
Alright, hold on.
Maurice,
X.
It's a thing smart people
You know
do.
something wrong with
Wyatt gets confused.
It's a thing smart people do.
x to the third minus 27, and then divided by, what do we have? X squared
Plus 4x minus 5.
Type it on test.
squared
I don't know, I've been working
plus, God, where's the plus sign?
So,
Plus
I'm
4x,
going to board in color.
4, oh my gosh, this is so hard. 4x minus 5,
Not coloring.
minus 5.
She drew a rose.
Done. Grab that. Got it. That's it. What's 27 divided by 5? It's like, it's about 6?
Yeah, about
5.5.
5.1.
5.4.
5.4. 5.2. Yeah.
Trev doesn't have
I'm just yelling stuff.
It's 5.4.
It's 5.4.
Wait, so since it's a negative, is it positive?
Dude, today, I guess the degree, so that's all I'm saying.
You know, I give you credit for that.
I guess the hypotenuse degree.
What are you doing?
Proud of us.
Imagine it doesn't work.
That's why. Faulty that doesn't stick to him.
Throw it away.
Throw it away.
I'm gonna break out.
It would. Oh my gosh. It would actually affect the Y-intercept.
That works now.
Okay. Hey,
Try it
hold
again.
on. Hey. Okay. All right. Didn't even think of that. All right. Because yesterday's problem, I didn't have that problem. All right. On this problem, to find Y-intercept, you always have to plug in zeros for x's. It's still the same rule. But what I forgot to do yesterday was, okay, you have to plug in zeros for x's. So I was like, oh, just plug in zeros up here. It cancels out all the x's. You still have x's on the bottom. And when you plug in zeros down here, these disappear, but that -5 wouldn't.
Right.
And yesterday, I think it did on the example I made up. So
Yeah, because it was 4 and 16.
yeah, so it was like, it was just gone. So the idea is that this number, whatever this is, so when I plug in 0, that's gone, so it's -27. Plug in zeros down here, those are gone. And -27 divided by -5,
Well, you
That
gotta
is
talk slower.
that is
You
a
gotta talk slower.
positive
You're going way too fast.
You're rapping right now.
-27.
27 divided by 5.
What is
Oh, is that one of the rules we were supposed to learn today?
Yes. So, all right. Yeah.
Wait, what's the decimal?
27 divided by 5. If I do it,
5.4.
It's not
let's see,
negative 27 divided by
No, I
negative
gotta do
5.
5.
Oh, I guess it would.
5 plus 25 to
It's 5.4.
0, 0, yeah, 5.4. Okay. So if you want to write a 0, comma 5.4.
Hey, didn't you have a calculator?
I don't even know how to do that.
All right.
I understand that you're
Already
inside
have
the board, but you've got
1,
to slow
2,
down.
3, 4, 5.4. Okay.
It's positive now?
Yes,
Yeah.
because the -27 divided by -5.
Oh.
So,
Wait, so that middle graph goes up then?
yeah, so that made a big difference, right? Because now my graph isn't on the bottom, it's on the top of my picture.
You're right.
Wait, so does that affect where your horizontal asymptote goes too?
No, the horizontal is affected by the front items.
Oh, so it doesn't?
Yeah, so we're going to look at that here in a minute. That's the new rule we have to talk about today.
Yes, it's recording. I'm excited to go watch this back.
Okay. All right. Hey, so are we good with the rules up till now? X-intercepts,
Yeah.
vertical,
Yep.
Y-intercept.
Mathematical M&M.
I think I have good enough notes.
Okay, all right. Now, hey, last thing we have to do is figure out the horizontal asymptote and slant. And then I'm going to go draw this thing. Okay, so this is the, now I consider these kind of one and the same. So this is kind of like rule 4. It's kind of a big rule. Because horizontal and slant, they go kind of the same direction. Slant and horizontal, they're both going kind of right to left. Or left to right, however you want to think of it. And so I consider them the same. Now, the rule that we talked about yesterday was if the powers in the front were the same, you look at the numbers up here, whatever these numbers are, that's in front of them, and you divide them. That's what we did yesterday. So I think we had like, I think it was like x squared and x squared, and it was, I don't even know what the number was. It was like
That's not happening
3x
today.
and 1. So that's what we had yesterday. So these are both squares.
That's
And
not
so you
happening.
looked at the 3 in front and the 1 that was in front, and you divide those two numbers. So your horizontal was at 3, okay? Because the powers were the same.
But today they're not.
They're not the
They're
same.
angles.
This is now at an angle because the powers are not the same. And what gives it away is that the top power is larger than the bottom power.
It's a positive slope.
So it is a positive slope. And so here's how you do it. Now this is going to be really tough. I'm mixing a lot of things together from pre-calc now. Okay, so the next thing we have to look at is to figure out where that slant goes. Is you actually have to physically divide. Now, I'm going to show you the shortcuts for this. You have to physically divide this polynomial, which is the top, divided by the bottom.
I don't got room for that.
Okay.
Nah.
Okay, hold on. So, there.
What?
Add another page so you can.
Think of Eric.
Okay. All right.
Oh, this is
So,
problematic.
okay, hold on.
Synthetic version, let's go.
Can I go do redo stats?
What?
Can I redo stats now?
No. Now, okay, so what we have to do is we have to divide these. And what this will, now why I'm choosing to do this. Now, this is the rule, you gotta listen. You would only have to do what I'm about to do is if the top is bigger than the bottom by 1. By 1. If the top is way bigger than the bottom, let's say this is like
Just forget about it.
Are you gonna make this?
x to the 17th, and this was like x squared, you would not have to do the rule I'm about to do. You only have to check for slant if the top is bigger than the bottom by 1 degree.
What if it's not?
If it's not bigger, it could be the situation like we talked about earlier, where they're the same power, and you just have to divide them to figure out where the number goes through. And if the bottom is larger than the top, it will always go through 0. And that's the next rule we're going to talk about. So I'll get to it.
But if the top is exponentially bigger than the bottom,
You
why
don't have to do this.
Why?
Because it would turn out to be a curve,
What do you do?
and you
then?
wouldn't have to do a
Leave it?
slant.
You just leave it?
You would just go on, and we would not have an asymptote horizontal.
Go.
So,
How
all
does
right,
it
now.
turn into a curve?
Okay, because watch. This will explain why it would turn out to be a curve. So this is the beauty of doing this. If you do it this way, what I'm about to do, long division, you don't have to go through the whole process. You can stop after the first 2 digits.
Cool.
Because it will give you the line you have to draw. That's the beauty of doing it the way I'm showing you. This is why we did it in pre-calc, I just didn't tell you it. So, what do you have to take times x squared? That would give me x to the 3rd. 1x. Okay, so I'm going to put it here. You only have to do 2, so I'm just going to put it over there. So 1x times this whole mess. Well, that would be x to the 3rd. X times 4x is 4x squared. And x
Can you
times
put it
negative
over
5.
the 0x because it's a 3, it's trinomial.
Yeah, well, I just put it because it's above the right letter. It's above the same term.
Okay.
Yeah, but you're right. It's 3 over because it's a trinomial. You're absolutely right. Okay, now.
I did it wrong.
Now, did everyone see what I did there? I figured out what I need to multiply by to get this item,
Wait,
this
are we
x squared,
subtracting?
to look like that one.
Yeah.
I had to multiply by 1x. Now, when you do this, you have to switch all the signs to subtract. I'm going to subtract, subtract, and subtract, which makes add. Not the best. And you're going to go straight down. So if I go straight down, what happens to the x to the 3rds?
Cancel.
Gone. 0 minus 4. Negative 4x squared, right? And 0 plus 5, that's 5x.
Then drop that.
Minus 20.
And drop down the next item. Now, we are not going to finish this all the way out. We're going to stop after the next one, because I'm going to just show you what happens.
So now it's a 4.
Okay, so now,
Do you get a remainder?
yeah, I don't even care what the remainder is. That's the beauty of doing this. So, now we're at negative 4, right?
That's really wrong.
4x, negative 4x squared. So what do I have to multiply this thing to make a negative 4x squared?
Negative 4.
A negative 4. Because if I multiply this thing by negative 4, I get negative 4x squared. Negative 4 times 4 is negative 16x. And negative 4 times 5 is positive 20. And here's the thing, you don't need to finish.
You already have the last.
I know. You don't need to finish. Here's why.
I
I already have the line I need to draw.
Pretty quickly.
Positive.
So,
Nice.
say it
What's
again.
the sign?
Positive.
No, it's a
I
negative.
specialize in
Oh, you
springs.
just do that, like you
Yeah,
said it.
so,
Not very-
so here's the idea. That, what's on top of the house, that equation, this is the rule that you guys never learned in pre-calc. This
That's a
equation
good
that's
thing.
sitting right here, that is the slanted line I'm about to draw. That is the horizontal slant that my graph will not cross. So it'll be at negative 4 for the y-intercept. Because again, you have to remember the rules in Algebra 1. It's going to hit negative 4 on the y-axis. It's going to go up 1 over 1, up 1 over 1. Because that's the slope. It's 1 over 1. Right? And I'm gonna draw that line, and I'm putting it a dash because this is my slant asymptote.
So does it just bounce off that the X-Intercept?
Wait, hold up. What happened?
Yeah, it's probably just gonna touch it and go off.
But it doesn't pass through it?
No, just because there wasn't another one. Questions?
So basically, that's just like the linear equation sort of thing?
Yeah, it's just a linear equation. You're absolutely right. So what I just drew here was slope-intercept form. That's what you did in your first test. It had a y-intercept of -4. It had a slope of 1/1. So that's my horizontal. So when I start drawing this mess of a graph, I can already figure out where I'm going. Because this horizontal is kind of guidelining where my tails are going to be, kind of roughly where I'm at.
Wait, why doesn't it pass through the positive?
Say it again?
Why
It's
doesn't
a
it
one
pass through
slope.
the x-intercept?
Just that?
No,
the
'cause-
asymptote.
I don't know, I'm confused.
You mean the slant? The
Yeah.
slant line? Slants, when you draw, you always just use a y-intercept and you always use slope because it's y equals mx plus b.
Go on us.
What percentage?
Like going into it.
Oh, you mean like this one right here?
We
Oh,
already
the
talked.
top.
That?
Yes.
No, I don't, that was from earlier. That was an x-intercept. We're not
They're all
gonna.
completely different things.
Yeah, they're all different things.
So how would the graph?
Now, here's what I'm thinking for the graph. Okay, I'm thinking that my graph is probably doing something like this. Now, the reason why I'm thinking that, because I had hit this y-intercept that was that weird 27/5, and it never hit the x-axis. Over here, I was definitely touching the x-axis
You
right
got
there.
a motion alert on your iPad.
Yeah, sorry, it's my camera's at home.
Somebody said he got emotional.
That's what I thought she said too. And so in that upper right corner, there, my graph's going that way. And on the other side, since this line keeps continuing, I'm thinking, if I'm going this right, I'm thinking that possibly this graph is probably down here. Now, the reason why is because I didn't hit the x-axis. There's a lot of space up here. I'm probably betting on that I'm probably down in that corner. I'm probably down here between the vertical and that slant, just because I didn't hit the x-axis and there's so much space that I probably would have hit it.
Oh, because the middle one
Because
already got there.
yeah, the middle one already went. So I'm thinking that's kind of where we're
So
at.
I can put an X through that little space.
Yeah, and if we look at the graph, it is actually doing that. It is actually now they did a super zoom on this thing, so you can kind of see what's going on here. And it, what was that? Yeah, I'm looking at Desmos' graph. So they did a super zoom out, and so this is actually like the real graph. Here's the real graph of it. The only thing I had wrong was that right side. It did hit the x-axis, but it didn't bounce off of it. And it makes sense now that I look back at it. When you look at the graph, because my multiplicity for that x-intercept wasn't 2, so I didn't bounce off of it.
Engineering.
So the left side there of my graph, or
So it
actually
goes
sorry, the
through
right
the
side,
slant
it actually passed through the
So the
x-axis.
slant does nothing.
The slant helped me guide where my things were. Like it told me where that lower corner
Yeah, but it
was.
goes right through the slant.
Yeah, it doesn't matter. The slant is just a guideline, and it helps me with my tails. Like I should have known that this thing went through it because.
So it does hit the x-axis or not?
Are you
Well, we hit the x-axis here, but that line went through it and went down because the multiplicity on my x-intercept, the multiplicity here was a 1, so I have to pass through it, not bounce off of it.
Oh,
So,
Please keep going through that horizontal.
yeah, you can go through horizontals because it's a guideline where the outside tails are going to be. It's just a guideline, right? Horizontals are like, they're fluid. You can go through them. It's not like a vertical where it would cause a mathematical error. A mathematical error is when you divide by 0. I can't divide by 0. So they're rigid. You can't go through verticals. But horizontals are just there, or slants are there, because it tells you where the outside tails are going to wrap around.
So does, if we don't,
And so that one right there in the middle doesn't go through that x-intercept.
This one right here.
Yeah.
I didn't have any x-intercepts here because when I factored this thing apart, I only had one x-intercept. So I knew that this thing wasn't going down. I didn't have any more x-intercepts. So I knew it had to be just straight up above. I don't know where it's at.
You didn't know where you guessed where
I guessed where the turning point was. That's what we're going to learn in the next chapter.
No, we don't have to.
We are. Question.
I'm on
Okay,
page
so
88.
how did you know it's like that? I was
Like this right side here?
Yeah.
Because my multiplicity on this graph, the X-intercepts, when we found it was 3, right? And the multiplicity, there was only one of them. So when they're odd powers, you have to pass through it. You can't bounce off of it like I thought you were doing.
So how'd you know that the slant one, that one on the left-hand side,
Alright.
left-hand side, how'd you know that was below the?
Because there was no X-intercepts up here, right? I wasn't gonna hit X-intercept except for 3. And so if there was this much space, my graph, if I were to draw up here, the graph has to kind of use as much space as it can before it hugs up against these.
I see.
And so like, I would have had to hit it. So it had to be down here to force that it wouldn't touch the X-axis.
Yeah.
Because the tails
You
have
have to have 3 of them, right?
Yeah, in this picture, there had to be 3 distinct graphs.
Because they have to get close.
Yeah. Questions?
So on that right side graph,
Yes.
so the bottom arrow that hugs against that.
It's gonna hug up against
But then that upper one, does that hug against?
hugs up against this.
It hugs against the
Yes, it
diagonal.
hugs up against the slant, because the slant is telling where the outside tails go.
So if we draw this on the test, will we get it wrong?
No, because you're making an educated guess. You have to have like a majority of the stuff correct. Hey, here's a great question. Okay, so Ward, he just asked, Ward, what if I didn't do this, right? Because I made the silly mistake where I went up 2. You won't be kind of wrong on a test because you're trying to put all these rules together that are just guidelines to try to make an accurate picture as best you can without technology, right? And so you're trying to make those guesses, so or using a calculator. So if you slipped up on like one little piece, it's not the end of the world. You're not going to miss points. You just have to try to rationalize what you're doing. Okay? All right, that's our only problem today. I know I was going to try to go through 2. These do take a while. I know, they're tough. Yeah. So we're going to look at 1 tomorrow. I still got that other type of horizontal we haven't talked about when it hits 0.
I haven't wanted to cry this bad in a while.
You're